question 3. So let's read the question. So a cyclist is descending down a mountain with constant acceleration. She passes through 3 checkpoints, P, Q, R. So let's sketch the diagram. So the cyclist is going down the mountain and it passes 3 points. So let's call it P, Q, and R. So at P, the velocity is 6. At Q, the velocity is x. And at R, the velocity is 20. Then the time taken to travel from P to R, so from P to R is 35 seconds. So let's look at question A. Part A asks us to find the acceleration. Okay, so remember from our first lesson, acceleration is the difference in velocity divided by time. And we can write difference in velocity as our final velocity subtract our initial velocity divided by t. So our final velocity at R is 20, our initial velocity at P is 6, and divided by our time, we know it takes us 35 seconds. So we can straight away find out that our acceleration is equals to 14 minus 35, which is equals to 0.4 meters per second squared. So let's have a look at what the question asks us to do next. So it's told us that given that T1 divided by T2 is equals to 4 divided by 3. So T1 is the time taken to travel from P to Q. So we know from P to Q is T1, and T2 is the time taken to travel from Q to R. From Q to R is T2. So let's read the question. So find the value of x. So we want to find out the velocity x. So again, we can look back to our 5 formulas. So let's just do our SWAT first. So SUVAT. So we're not given any information of our displacement. So it's not anything related to displacement. And we know that our initial velocity, so let's say our initial velocity is going to be our x. And our final velocity is going to be 20. And we are given in the question, acceleration is constant. And we just found out that from part A, acceleration is 0.4. Then we could find out time using this information. So let's find out time for T2. Similarly, if you did it the other way, so there's 2 ways you could do this. So you could also do SUVAT. So your 6 is your initial velocity, your final velocity v is x, and your acceleration is 0.4. So with this one, you're going to find out T1, and this one you find out T2 to help you find out your x. So let's look at how can we find out the time for t2. So with the information given, we know that t1 plus t2 is going to equal 35 seconds, because from P to R is 35 seconds. So, and we're given the formula T1 divided by T2. So T1 divided by T2 is equals to 4/3. So we know that T1 plus T2 equals 35. So we want to find out T2 is. So what we can do is that we can rearrange the equation to find out what T2 is in here. So let's substitute. So T1 would equals to 35, take away T2. So let's substitute this into here. So we have 35, take away T2, divide by T2 equals 4/3. So just rearrange our equation to find T2. So I have 35 minus T2 equals 4/3 multiplied by T2. So multiplied by 3 on each side. So I have 105, take away T2 equals 42. Remember, we had to also multiply that by 3, so it's minus 3T2. So 3 times 35 is 105. 3 times minus T2 is minus 3T2. So 105 is going to equals, so I plus 3T2 on both sides, so I have 7T2. So I know T2 going to be 105 divided by 7, which is 15 seconds. So I know T2 is 15 seconds. So just looking back to our equations. So this equation 1 is the one we don't need s. So we're just going to use V equals AT plus U. So V equals UT V equals AT plus U. So we know that V is 20, A is 0.5, we know T is 15, and plus U, which is X, so now we can find out X. So 0.4 times 15 is 20 equals 6. Plus X, so we know X is going to equals to 14. So remember, X is the velocity, so it's going to be 14 meters per second. And then part C asks us to find the distance between P and R. So this is, we're going to use our equation number 2, that S equals U plus V over 2 multiplied by T. So we know our initial is 6, final is 20. Half it, multiply by time, which we taught at the beginning, 35. Then just type into our calculator. So you should have 455 meters. So let's have a look at question 4. So a particle is traveling, a particle passes point A